My name is Kasim Tumen. I work for Sparks, an innovation lab for Staples. And we were known as Runa before. After acquisition, that's our new name. And I'm here to pitch why you should consider working with us. Somebody suggested that I should, first of all, I really thank Cognitect arranging ClojureConf, and we're proud to be the sponsor. And speaking of Cognitect, we do work with guys from Cognitect. And somebody suggested that I should register fakerichhickey.com. And I'm really considering it seriously. Sorry, I got to talk to Rich before I do that, I guess. Anyway, so what I would like to talk here today is basically I'd like to, you can find out a lot of details, our who we are, what do we do, and our culture and vision, all of that on our sparks.com website. And there are brochures and stuff. But what I would like to briefly mention is our tech stack, our tech culture, and our vision, so that if any of those rings a bell to you, or you have any other suggestion that we can do better than that, the things that we're using, I'll be happy to talk to you. We have guys from our office here who would be really excited to share and talk to you guys as well. Okay, why you should consider working with us? I'd like to start with the tech stack that we have. Clojure, of course. Initially, we came to Clojure for its immutability, concurrency. After a few years of working with it, we realized the most important thing for us is the distance between the requirement and the implementation, because that has been over and time again is our secret weapon to be successful startup and finally get noticed by Staples and acquired us. And since then, we've been delivering awesome products. And for our data team, they use Spark. They started with Hadoop, and they got tired of it at some point, babysitting. And they started using Spark. It seems that they like it a lot. And we use Postgres. We've tried many databases. We tried, and that's has been performing really well for us so far. And Pure Jetty. And I talked to some people, why not Ring and all the Composer and other stuff that in the ecosystem, they're great for the purposes that they're designed for. But we have a very strict SLA. And we would like to really close to the bare metal as close as possible. So we just wrap Jetty. And for concurrent, we use Java Util Concurrent. That's like a main staple for us over the years to tackle any kind of concurrent issues, concurrency, performance-related issues. And we use, one of my personal favorites is a Google Guava library. A lot of cool stuff. You guys should check this out. And it really, really helps you in terms of performance and in terms of a lot of abstraction you build on top of it. And we use Redshift for our data warehousing, for ETLs. And among other things, we use in-house libraries, tools. One example that I can give you is Chef. We started with using Chef when it was Runa, and then Chef did enough damage to us that we decided that we need to come up with our own solution. We have an in-house solution where we use Perl, Bash, Makefile. It's super awesome. It works really well. We can actually bring up the entire production within a few hours with that tool. And we hope to be able to someday open source it, share it, but we're not there yet. Our tech culture, very matrix-driven. People come with the library, cool tool, and all of the stuff. We'll say, okay, fine, here's where we are. If you think that you can do better than this, show me the numbers, we'll take a look. Very simple. Flat hierarchy, no senior, junior, architect, all of this. We have engineers, coworkers, great engineers working together. If you have a great idea, there's no limit that you can experiment with it, show us the numbers, prove us that that's better than what we have, we'll go for it. Lean, agile, pragmatic, whatever you name it. Very, very open, and you know, we have daily stand-up, Scrum, and all of this, but we're not subscribing to any kind of methodology or dogmatic way, but very pragmatic. Experimentation. We do have an experimentation platform, which is, you know, a nature of an e-commerce world. You need to do A/B testing and all of this, but we do A to Z testing. It's a multi-paradigm experimentation platform. But at the same time, our culture is, you know, if you think that's a good framework, library, not a framework much, but a library of tools and a language, or fits that the domain, the problem that you're solving, you know, experiment with it, show us. And we'll take that. And we'd like to dive deep. We really get to the bottom of whatever we do. We build up our application. We have very strict SLA. Most of the times, we need to deliver 99.5 percentile. Most of the time, requirement is under 30 milliseconds. And we really, really need to think. To achieve that performance is not easy. Over the years, we found that the best way to do it is to start from the small functional level that you write, and every step of the way measure and build up on top of it. That's how you gain performance. And any performance-related stuff, and if you know, there's a disruptor. The Martin Thompson is the guy to follow on that if you're really into performance-related stuff. And simplify. This is really important for us. One of the reasons is Clojure has enabled us to simplify things. And Clojure has this tremendous power that I really don't have to mention here, but it helps us to really see the core of the problem and abstract the real core in a nice way so that we can build on top of more abstraction on top of it. But such a way that it is manageable, because the language never ever stands in your way in terms of implementing what you want to do, and that's why we love and help us simplify. And we have excellent test coverage. Our engineers are very, that's one of the areas that our engineers really, really subscribe to. We test our products extensively. It's extremely important because a lot of our products is customer-facing. We really don't want to throw, you know, stack traces and all the exceptions to the face of customer, and it's really important that we cover as much as we can. And there's some problems we tackle. It sounds interesting. I'm just presenting here so that, you know, if you're interested, come talk to us. We'll share more detail. There's like an issue where concurrent calls should result in just a single evaluation of our personalization engine. There's one issue where, you know, there's 8, 10, or 20 concurrent call comes to our service, and we need to be able to say, hey, we just evaluated once, and we'll spit out whatever the thing that you're requiring for. It looks trivial, but in the details of it, there are ways to implement it really well and implement it really bad. And how to make sure high availability for growing data-driven micro APIs. Mainly, it's Jetty wrapped on web services exposed to HTTP endpoints. And how to make sure the data feeds in our system is reliable and fault-tolerant. This is actually an extremely important part. We have, working with Staple, they have, you know, as a big company, they have data in different places. FTP, SFTP, SQL, XS, somewhere, right? And we need to be able to say we can extract the data reliably in fault-tolerant manner so that the data that comes to our system, so that we can use it to do you know, modeling. And again, how to achieve 10 milliseconds per request and 40,000 requests per second SLA. That has been one of our core product that we have done in the past while we were still a startup for a big e-commerce company. And we're so proud of that we can, you know, reach that level in terms of prediction engine, which is one of the things that we did as a shipping prediction. So, And then how to personalize and recommend products and offers in near real time. That's a very tough problem. And we have a lot of work to do to solve that. And our vision. Since we joined Staples, from up top, they have been very supportive. And they have a vision where we get to a point where we have 80-20, 80% for the company, 20% of your own time doing your own projects. And that's the thing that we innovate. And there's a strong support for that. Present papers to conferences, open source tools, internal libraries we have, and build world's best product personalization engine and best recommendation engine. At the end of the day, I mean, it's all about giving a great customer experience to 50 million users that Staples have, which is the third largest e-commerce in the US. So that's about it. Please come talk to us, and I thank you for your time.
Thank you. Our next speaker is going to be David James. I'm going to give him a second to switch over here. And he's going to be talking about something called Fondo, and I will let him tell you more about what that is.
Good afternoon. My name is David James. I'm presenting today. Joshua Miller has been helping out a lot on this project. This is a work in progress. It's a specification for distributed, immutable, derived addressable data. I'll explain what that means. The reason I'm talking is I think there's a lot of overlap between what we've learned with Clojure and where we might be able to go with networked data. Go clicker. Okay. Okay, many of us here write programs that interact with data via networks. That can mean discovering data, using it, transforming it, or publishing it, lots of other things. In practice, we use HTTP to consume and publish our data over networks. It's just kind of what we do. I want to read a quote by Juan Bennett. So far, HTTP is the most successful distributed system of files ever deployed. Coupled with the browser, HTTP has had enormous technical and social impact. It has become the de facto way to transmit files across the internet, yet it fails to take advantage of dozens of brilliant file distribution techniques invented in the last 15 years. That's a cool paper. It's the Interplanetary File System. Much better thought out than what I'm about to tell you about. HTTP is great, and we can do better. So we have a plan called Fondo, which is an Esperanto word that means foundation. It's one way to do network data better. It's inspired by a lot of concepts in Clojure. By we, it's an open we. Myself and Joshua have started. I've got some other friends interested. I'd like to get more people interested. My goal here is, maybe you like what I'm talking about, maybe you don't, but I do want people to get a little dissatisfied with the status quo of distributing files with HTTP. And I think anyone in the audience has problems you want to solve. I encourage you to think about those, think bigger, and pull together interesting ideas that you like and see what you get. That's kind of how this came about. I'm stealing a lot of ideas from others. Here are the design goals that we're starting with, that we care about. I'm open to broadening the list, contracting it, but here's where we are now. So, and these I go into on the later slides. This is just the quick summary. Provide content-based addressability for data distributed across devices and networks. Diverse devices and networks. Ensure data mutability and integrity. Support derived data efficiently. And embrace the diversity of underlying systems. Okay, so the first one kind of boils down to decoupling location from the way you get at it. So in Fondo, an address is a name, not a specification of location. So this is more like a URN, which is a flavor of URI, which people may or may not know about, but you could do things like go from an ISBN number to identify a book, even if you don't care where the book is located on a server. And the other cool thing about decoupling location is that you can let the system be smart about choosing the data that's closer to you or has certain desirable properties. Maybe you're talking about a mesh network of distributed mobile devices, and they can't guarantee at any one time which of them is going to be connected, but they still need to get access to some data. This kind of system, like Fondo, but there's lots of others that view this as a goal. Another interesting goal that I hope Clojure developers will be really interested in this idea is the idea of derived data. So values can be derived from other values. You can transform data in arbitrary ways. We think we're going to need to impose a minimal set of types. And there's two ways that you can derive data. One is by using persistent data structures, because that decreases the cost of doing a cheap modification. Another way to do it is with actually a functional transformation. So you might imagine person A gives you a 10 gigabyte data set, person B gives you a 10 gigabyte data set, person C only joins them. Now, if someone comes along and wants to consume the third item, should they have to download the whole 20 gigabytes if they already have the original two 10 gigabyte files? I don't think they should. They should be able to take what they already have, it's immutable, apply a functional transformation, and there they go. This fourth one I haven't seen mentioned as much. There's a lot of great distributed file systems out there. But if you wanted to run an organization on kind of one standard, maybe it's Fondo, maybe it's something else, you don't want to impose necessarily one underlying technology. So how do you allow these different systems to work together? They all have different distributed system guarantees. They all handle these guarantees in different ways: consistency, availability, partition tolerance. I'm not an expert in this field, but what I'd like to do is have the system as a whole be able to tolerate that diversity and offer up your data in a sane way that makes it easier to work with. So it's a heterogeneous system that builds for immutability. So what that means in practice is that it can't guarantee availability. You might ask Fondo for a bit of data. It might have to look around the network. The data may not be available right then. I don't expect it to be a system that holds all of the data. It probably is just going to point to other data systems. Let's see, I'm checking time. So I want to talk a little bit about benefits. There's 4 layers of benefits ranging from sort of the programmatic up to sort of the community level. So at the bottom level is this idea, if you're writing a data consumer, if you have to deal with a fragmented set of standards, it's going to be harder to work with. If you go with some standard way of consuming data with immutability, your job should be much easier as a data consumer. Another interesting to think about is at the network level, data sets should be cheaper to discover and faster to transfer, especially with derived data. So one data provider might offer sort of a time series set of data. Another might just want to summarize it. If you already have the time series, you don't need to re-download it. You just run a computation to get the summary. Another benefit is at the organizational level. If you're thinking about how do you find data from another part of the world or another part of your organization, if you just use a URL, you can't be sure what's under that URL. So it'd be nice to know that what's associated with that ID is actually the data you're expecting. And you're not forcing someone else to use whatever database you use. So it's tolerant of that. And this is, this may never happen, but if this was adopted broadly, it could be a nice data foundation for the internet. We welcome participation, all kinds of criticism, whether it be, hey, I want to help, or hey, here's a time bomb in your design goals. They may not theoretically work together, but we do want to transform how people think about and use network data. And we have a GitHub repository. It's just a start, but we welcome participation. And thank you very much.
Thanks a lot. Up next, we're going to have Sean LeBron, and we need to get switched over to the other presentation here. And he's going to be talking about, well, I'll let him tell you what he's going to talk about. Sean LeBron.
Hi, thanks. So my name is Sean. I'm going to be talking about ClojureScript in regards to accessibility, resources, and tools. Chris Oakman and I have been working on a few things with regard to this, and I'm going to be talking about that. So we work at a company called Pros. We are a publicly traded company in Houston, Texas. I'm a ClojureScript developer, and we build web applications specifically for the science of airline ticket pricing. So we provide that to our customer analysts through these web applications. But before then, I was a JavaScript game developer, and this is something that I made. It was an accurate port of Pac-Man that is demonstrating how the ghosts are behaving. So it's a very educational tool, and they turn into cookies. After that, I went full-time independent. I was an indie game developer last year working on this game for the iPhone. It was made completely in JavaScript. I do not recommend that. These are the tools that I built for the game. So in addition to the engine, I made a bunch of tools for sculpting pterodactyl paths, selecting the background layers and animating them and attaching collision geometry, as well as creating the menu layouts. In addition to that, I found the development experience a lot more interesting than the product. The game was actually really fun, but I wanted to write. It was sort of an experiment to see how, if it was of value to write all about our development experience. So I'm really big into education like this. So after the game made no money, I joined a company. Chris talked to me and he was telling me this cool thing about ClojureScript, and I really struggled with maintaining the complexity of what I was doing. Games are very complex. So he told me about ClojureScript. I was super excited about it, and I joined the company. And they allowed me to learn ClojureScript and to build tools with it, web applications with it. 8 developers. I was one of them, had transitioned from JavaScript to ClojureScript. And we are a wide variety of developers. We have some old hats, and we have people who are fresh out of MakerSquare. So since I like games, one of my friends, Elaine, she wanted to celebrate Tetris's 30th birthday. So I was like, well, we're learning ClojureScript. Why don't we just build a game so we can throw a party and have a multiplayer competition? So it's actually showing you all the different themes of Tetris over the past 30 years. And you get to play with that. Chris Oakman joined at the last minute and whipped up this quick dashboard, so we projected it while we were playing, and you could see he was in the lead and they were swapping. It was really cool. After that, in sort of the same spirit of what I did with Pterodactyl Attack, I wanted to explain how we built this thing. So these slides are sort of another experiment to see if it's valuable to sort of illustrate how we did all this stuff step by step. And it really shocked me how cool it was to do in ClojureScript. It was very clean. So at Pros, we started building different projects. Let me check my time here. I did not start the time. Okay, started using Ohm. I built a project in Ohm, and Chris Oakman, he doesn't really like frameworks, so he used Quiescent. So that was a really cool minimal implementation. We started having boot camp sessions to start introducing people to ClojureScript at the company. Some new people joined, but we sort of got some complaints about the resources and tooling. So we decided that ClojureScript definitely needs these 2 things. We need a website. We need a website, guys. And we needed an easier compiler tool. So Chris Oakman hit this problem hard. He started creating the first part of the website. CLJS.info is sort of our test bed for what maybe the website will look like. And the cheat sheet is, of course, a very important component of that. So what he did is he started combining the best parts of 3 tools, like ClojureDocs.org, really nice resource for that. Grimoire is amazing, and you can filter and search all through the different symbols. And Clojure.org has a cheat sheet as well. But what he did is he kind of organized these things into sort of basic categories. So at the very top, you can see the most frequently used things like def, in, if, let, whatever. And I'm not sure if you can see that at the top, but we would give you visual cues, like these are vectors, these are operations for vectors, these are operations for maps and strings, and JavaScript interrupt. So you're not going to find ClojureScript-specific things in those Clojure docs. So this is a start. He's also a great designer, so he's starting to really write the tooltips for it, and they make it, he makes it look really nice. And in addition to displaying the error, he's not just displaying the doc strings, he's wanting to create like more human-readable versions of these functions to be more accessible. So that's the website. We're kind of working on that, but in addition to that, we want the compiler to be a little bit easier to use. Two principles here. I don't think we should make JavaScript developers leave their favorite editor. If they're moving to ClojureScript, learning ClojureScript itself is going to be difficult, and the tooling should be kind of transparent to that. And a better default compiler experience. This is Windows. This is what your errors look like whenever you're compiling. I left out parentheses, and I get this. It's not color-coded at all in Windows because it doesn't handle ANSI color codes. And if you see that line in the middle, that's where your error is. CLJS build is sort of the tool that produces that output. But I went to 3 sessions yesterday for Cursive, Light Table, and Cider, and they're really amazing. So that's sort of the community's answer to this, is sort of provide a tool over Lion. So for ClojureCup, I thought it would be cool and kind of a weird experiment to just wrap it on top of like a minimal IDE. It's not an IDE, but it provides like the basic parts of it, like a build button, and it kind of shows you the errors, only the errors you're interested in, as well as warnings. So you would use this sort of beside your favorite editor. And of course, I can't build anything in 2 days, so it didn't work that well. So this is something that Chris Oakman started as well. He kind of started from scratch. I tried to build it into CLJS build, the plugin, but we created a Node WebKit. No, not Node WebKit. It's like it, but it's called Atom Shell. So it's an application. So you want to compile your project, just double-click this application. And I just opened the Tetris project, and you can see that it is displaying the different types, the different builds detected from your project.clj file. And up at the top, you can select which projects to build. You can toggle off the flag for recompiling whenever you change the file. And I'm just going to hit that button. And of course, I'm going to fast forward through this because the initial compilation is a little slow. Okay, and right now, just to show what it's doing, I'm going to remove parentheses. The same error that was produced on that Windows output is now just like red lines there. We want to format them better and even like display the code under it to just kind of place a caret like under the position of the error. And you can see once you recompile it, it's just what you would expect. And I'm going to use a symbol that I've not declared yet. So it produces a warning. So this is just a very minimal layer over the compiler. It's I think it'll be a nice accessibility thing for people who are wanting to use this. Okay, thanks. Thanks to Chris Oakman for building these tools. I'm really starting to help out with it, and you can go to GitHub for the build tool as well as the cheat sheet. And we need help. I'm going to ask you guys about like compiler stuff because I need that. And even though these are small things, I think small things are really important, especially if you want ClojureScript to be a mainstream language, which I think it really deserves. Thank you.
All right, thanks a lot. For our final presentation, we'll have Reed Draper, and let's see, there we go. And take it away, Reed.
Thank you. How many of you have ever found yourself executing a search algorithm in your daily life or as a programmer? I start to feel really bad about doing that, and that feels like work that the computer should be doing. So I'm going to tell you a little bit about how TestCheck simplifies counterexamples automatically for you. So this is a test case that failed in a test of a Clojure data structure. This is a bug that was fixed in Clojure 1.6. And this was generated from a random test. And this is the kind of thing that you actually have a failing test case here that you definitely would not have written a unit test for. And you could probably try and figure out what's going on. I think we all have an idea that not all of this giant wall of code here contributes to the bug. But I don't want to start seeing like, oh, what happens if we remove that persistent bang call, or what happens if we don't conj 117? So TestCheck does that for you. And you get a failing test case like this. In the case of this bug, 109 and -110 have the same hash code. I wouldn't figure that out. Test check can also simplify other kinds of data structures. So this is a failing test case for a situation where someone forgot to use PR_stir and used print instead. Turns out that the problem was the space character. So I'm going to tell you a little bit about how test check does this completely automatically. None of what I'm about to describe do you need to actually understand in order to successfully use test check. But I think it uses some cool techniques, and it might be fun to look at the implementation. So when you write test check properties, you use generators. A generator describes a way to generate and shrink some particular domain. So in this case, we're creating a generator that generates values between 0 and 100, and we can sample those values. So on first approximation, it might seem like a generator is a function from some random state to some random value that fits in that domain. So we pass in a random state here to this integer generator, we get 61. Maybe the next time we get 47, or we get 9. This is actually not how test check generators work. In addition to generating a number, we actually generate a tree that's not shown to your program. This is sort of done behind the scenes. But we also generate the shrink tree, which lazily describes how to shrink the number 9. And as you use the different test check combinators, this tree gets manipulated behind the scenes, as does the random values that you generate. So here is an expanded shrink tree for the number 9. And let's say that we want to use the fmap combinator, which allows us to apply a function to every value that's generated. So we're going to generate integers and multiply them all by 2. So now we have our number 9, which has now been multiplied by 2. We now have 18 at the top of our tree. But we've also applied this function to every single node in this tree. But we can do so lazily, so that we only actually realize this tree as we search it. So now we have a tree where every node has been multiplied by 2. In addition, we can use the same technique for some of the more complex combinators. So this is the type signature of a combinator called bind. It allows you to build generators based on the values of other generators. So say you have a generator of A's and a function that takes an A and returns a generator of B's. You can combine those together to get a generator of B's. So an example of that, you might have a power of 2 generator that generates 2, 4, 8, 16, etc. And then you want to create a vector whose length is one of these random powers of 2. So we bind this power of 2 generator to a function that takes that power of 2 and returns a vector generator that uses that length. So let's look how shrinking works for that. So let's say that we generate 5, 23, and 1 for a first generator. We create this shrink tree. Then we apply this function to it, and now we have a shrink tree where the values are shrink trees. And it turns out we can actually just use a little algorithm to flatten the tree one layer. This is called joining. And we now have a tree that is just wider and a little bit deeper, and it's actually incorporating the shrink tree for the original generator and the generator that you've passed as a second argument to bind. So when you compose these generators together, you still get the full power of shrinking without ever having to think about it. Anyway, that's all I have. If you're interested in this, go check out the GitHub page, or come find me afterward to come talk about this or ask more questions. Thank you.